So as I said, did most the wiring on my kitchen table here. Unfortunately, you see the card's on, 5 volts, power supply is working. As you can see, I got all this stuff unplugged here. By the way, for you that don't know, this type of driver, the plugs pull out. You can pull these plugs out so that you can get a screwdriver in there to tighten the wiring. Unfortunately, what would have been my A drive here was bellowing smoke when I first turned it on. I unplugged the other 3 because I'm not sure if they have a problem or if they don't have a problem. Now, I don't have the motors connected up, and hopefully that didn't cause a problem. But the A driver, I'm sure it's toast because it was bellowing smoke. Why? I don't have a clue. So I guess I'm going to have to continue on. I'll plug one more driver in just to see. Hopefully I'm not going to blow that one up too. If I do, then it's probably because the motor's not connected, but that doesn't make any sense to me. They shouldn't destroy themselves because there's no motor connected. But I got to move on, so I'll give it a try. Okay, well, I plugged in the X power and it's not smoking, so I guess I just had a bad driver here. Thankfully it didn't blow up the power supply. I still have the other 2, the Y and the Z axis unplugged. This was going to be my A axis. I guess I'm not going to have an A axis until I replace this driver. Cheap enough, I don't know, $10, $12, I forget what it costs, maybe even less than that. But that was a surprise, the belching of smoke. Never like to see smoke belching out of components. Well, the good news is that I verified that's the only bad card I have. I did a little buzzing around once I took the cover off. This is not the bad card, but there is a big burnt resistor on it, and there seems to be a short directly from the power input to ground, 36 volts to ground. Like I said, I'm lucky it didn't take the power supply out, but all the other drivers look okay, so I got a new driver on order. But in the meantime, let's see if I can get a light over here. I realized that when I had to take these things out first time around, they were screwed directly to the bottom of the box, and it suddenly dawned on me that if I ever have to replace a driver because the column is about from here to here, you know, it's wider than that, but about, you know, the column is behind this box, okay, and it's bolted to the column. If I ever had to take a driver out because I had some screws that were countersunk into the box and flat with the column, so that the box would sit flat on the back of the column. I'm talking about the mill, the column on the mill now. There's a hole right there. That's a bolt that bolts into that column. I suddenly realized that if I ever had to get these things out, I was in for a big job, because I couldn't get these screws out because they're on the back. They were on the back side of the box, and the only way to get those screws out of there is to remove the box. And to remove the box, I would have to remove the wiring, the power from the box above it, the red box, the original OEM box, you know, the motor speed controller, and all the servo connections or stepper motor connections right here. They're not in here yet, but here they'd be on this side of the plugs. these four connections on here, 4, 8, 12, there'll be 16. There's 3 cables that go through here, and I'd have to take all of that out. All of that has to come out just to get the box off, just so that I could replace a driver. That's no good. So what I did was, I got on a computer there and I designed this little plate. And you don't need a computer to do this, by the way. I mean, you can see it's basically a square piece of plastic. I designed it so that the plate is attached from the rear. Okay, it's what is this, HDPE plastic. The plate is attached by 4 screws from the rear, and of course they're shallow screws because you can't have them protruding. And you see I got some screws here. I'm only showing them on one side. The hole's on the other side here. You can see it there. So you can move this light around here. Can never get as much light as I want. Alright, so anyway, these will go in here like this. The screws are accessible now from inside the box, and I can get a driver out of there whenever I want. And so the 4 drivers will attach that way. It was a lot of work, tear everything out of here again, but I'm sure sometime in the future I'll be thanking myself. So anyway, that's what I did for the last 3-4 hours, I guess. I procrastinated a lot because I hate tearing stuff apart once I put it together, but like I said, it would be a major to-do to have to pull the cable out of here, the cables and everything else, just to get the box off, to take off a single screw. You know, that's the way it was going too. It would have been these screws here on this side. Right here, you see the holes here. These screws here, I wouldn't have been able to get out because they were screwed from the back side. So, alright. Glad that's finished, done and over with. Okay, sorry I got distracted on that, that bad driver. This is where we should be at. Had things gone okay. You can see I've got my fan here, and I've got a couple of wall warts plugged in here. One is 5 volts, and the other one is 12 volts. This is 5 volts, 2 amps, 12 volts, 1.5 amps. Probably could get away with an amp or even a 1/2 amp each. 12 volts is used for the fan. It's also used on the 5-axis controller, but my suspicions, since I don't have a schematic, so I can't analyze anything on that card, I suspect that the 12 volts on the card, it says 12 to 24, it's an input to the card, is probably used for the relay. And in this application we're not using the relay, so probably wouldn't matter if I had it or not, but I needed it for the fan. So I went ahead and I wired it up to the card. I'm talking about the 5-axis controller down here now. There's an input for 12 to 24 volts. My power supply is 36, okay, so I couldn't use the power supply. So the 2 DC wall wart inputs come in through a grommet on the front panel there, and they're wired to the card. 5 volts for the card, 12 volts for the card, 12 volts for the fan. Cards are back in here, but of course I'm short one, my A-axis. I'll have to wait until that comes in, I guess, the new card. I still haven't put my switch. It's hanging in the bottom here. This goes through the front. Let's say the front. Goes through this hole right here on the back. It's this one here. I don't want to have the box fall down. It's hard to do this with one hand. Right here, and the column of of the mill is here, so that'll be accessible to me from the front of the mill, that on-off switch. I left the hole open here for exhaust for the fan. This thing's getting heavy. Woo. And I think I mentioned already, this is the power that's going to get routed up to the original speed controller. And that's about it. Oop. I don't know if I accidentally turned the camera off or not, but I just switched it back on. Oh, the two outlets here, by the way. The switch controls the one outlet with the wall warts, and it controls the power supply and all the electronics in this box. So when the switch is off, everything's off in this box. However, one outlet here, which one am I pointing to? This one. This outlet here is hot all the time, as long as the the power cord's plugged in. And that I'll probably use for the computer. So I think I'm ready to haul this thing in into the garage and hook up the X, Y, and Z. And I don't have any table yet. I've yet to make it. I have a rotary table I'm going to convert. But when I get the drivers in, I'll do that. And that's about where we are at right now. So I might tie some of this stuff up a little bit and neaten it up a little bit in there. But all in all, I'm happy, even with the one snafu. Cost me some time, but what are you going to do?